Hello everyone, thank you for watching this video. Let's start with this problem. So the problem says show that if a, b, c are positive real numbers, then a plus b times b plus c times c plus a is greater than or equal 8 abc. Okay, then there's another part of this question, another question that says and the equality holds only if a equals b equals c. So let's begin with the first question. So to answer this question, we have a hint here. The exercise or the problem says that we can use the arithmetic-geometric mean inequality to try to prove this inequality here. So what does it mean? What is this arithmetic-geometric mean inequality? Let A1, A2, A3, A4, etc. until AN. So we have n positive real numbers. Positive real numbers, okay? The arithmetic mean is equal, arithmetic mean of these n numbers is the sum of these numbers, which is a1 plus a2 plus an over n, the number of these numbers. The geometric mean is equal exactly to the nth root of the product a1, a2, a3 times an. So we have the product of all the n numbers. Now this inequality, the arithmetic geometric mean inequality, means that the geometric mean is less than the arithmetic mean, or equal, of course, which can be written as nth root of a1, a2, a3, etc. times an is less or equal to the sum a1 plus a2 plus a3 plus an over n, all of them over n. So this is a remainder of the arithmetic geometric mean inequality. Now, how can we use this inequality to prove this required inequality? So let's start with this product here. So a plus b, b plus c times c plus a is equal to, let's distribute this product. So it's a plus b, and then we'll distribute this second product here. So it's bc plus c squared cc plus ba plus ab plus ca plus ac. Now we distribute the whole product. So abc ac squared plus ac squared plus aab, that's a squared b, plus a times ac, a squared c, plus now b times bc, b squared, c, plus b times c squared, plus b times ab, that's a b squared, plus a times plus b times ac, that's a bc again. So we have twice abc, so it goes 2abc plus the rest. That rest we can write it ac squared plus a squared c plus ab squared plus a squared b plus bc squared plus b squared c. Okay, now we see that this product a plus b times a plus b plus c times c plus e yields 2abc plus another sum of some products here. So 2abc is what we want to see in the right hand side, or the lesser side, the smaller side, which is 8abc. So we have 2abc. Now let's take this sum here and apply the arithmetic geometric mean to those numbers. There are exactly 1, 2, 3, 4, 5, 6 numbers. So this is a1. If we return to this arithmetic geometric mean, a1, a2, we need n numbers, positive numbers. So we have 6 numbers, positive, of course. ac, that's a1, ac squared, a2, a3, a4, a5, and a6. So the arithmetic geometric mean inequality can be written for these 6 numbers as follows: ac squared plus a squared c plus plus ab squared plus b a squared b plus bc squared plus b squared c are over the number 6 is greater than the 6th root, because n equals 6 here, 6th root of the product of all these 6 numbers. Okay, so ac squared times a squared c times ab squared times a squared b times bc squared times b squared c. Now let's simplify this product here. So it's the 6th root of, now a times a squared times a times, we can rearrange the products here, the factors of this product, so to have all the numbers that have the same base, which is a, for example. So a times a squared times a squared, that's a times the sum of the powers, so 1 plus 2 plus 1 plus 2, that's 6 exactly. Now the same for b, where b squared times b times b times b squared, that's 2, the sum of the powers, that's 2 plus 1 plus 1 plus 2, that's exactly 6. And you can still see that for the number c is the same again, c squared times c squared times c, which is c to the 6th. Since this is a product of 3 numbers that have the same power, so we have the product of the numbers to the power 6 and roots. Let's remind that here. The nth root of a to the n is equal to a, when a of course is positive. So we have this equal to abc. That means that this whole sum, ac squared plus a squared c plus ab squared plus a squared b plus bc squared plus b squared c is superior to 6 abc, since we have over 6 when multiply both sides by 6, and we have exactly this inequality here. Now what do we need? We see that this sum here is exactly here. So it needs only to add, we need to add 2abc. That's what we will do. So 2abc plus is greater than 6abc plus 2abc, since we added 2abc to one side, we need to add the same number to the other side. So we have exactly this sum, which is exactly here, which is equal to a plus b times b plus c times c plus a is greater than exactly here 8 abc. So we proved this the required inequality. That's the inequality we were asked to prove. Now, second part of this question. Let's show that the equality holds only if a equals b equals c. Now, in this same arithmetic geometric mean, we have this becomes an equality we have root n of a1, a2, en is equal, it becomes an equality to a1 plus a2 plus an over n. This equality holds only if a1 equals a2 equals a3, etc. to an equals en. So if only all the numbers are equal. So if we apply this, to the inequality we have here, so this would be an equality if, and only if, this is an equality. That means that this should be an equality. So, and this is exactly this inequality. So we have the equality when the 6 numbers are equal. That means ac squared equals a squared c equals ab squared equals b squared, or a squared b equals bc squared equals b squared c. So this can give us exactly, we can write that as a system. So ac squared equals a squared c and a b squared equals a squared b, and bc squared equals b squared c. So this we can divide by ac or write it as a difference. So that is equal to 0. So ab squared minus a squared b is equal to 0, and bc squared minus b squared c equals to 0. We can factor, we have a common factor in the first one, so that's ac. We have a and c, both are factors, so we factor by ac. So we have left here c and a minus a, okay, equals 0. And the second one we can factor by ab, and we have b b minus a equals to 0. Third one, I can factor bc, so we have c minus b. Now since AC, AB and BC are all non-zero, we have C minus A equals 0 and B minus A equals 0 and C minus B equals 0, which is equivalent to C minus A equals 0 means A equals C, and here we have E equals B and B equals C. And that means exactly B equals A equals C. I hope that the next video maybe we have another new problem. Thank you very much.